Hello everyone. In this session, let's discuss about copy assignment operator and understand its syntax in detail and when this copy assignment operator is called and what is the best way to write the copy assignment operator. So I have pre-written some of the classes here. So one is address class. It's the same example what I used in copy constructor. So this is address class with a parameterized constructor and some getters and setters. Then I have a person class and with three data members, age, name, and the address, which is a pointer. Okay. So I already written a copy constructor here. Now I need to write a assignment operator. Before I write a assignment operator, let's see what happens or when the assignment operator is. Let's see when the assignment operator is called. So what do you mean by copy assignment operator? So copy assignment operator is this overloading of this operator equal to operator, right? Overloading of this equal to operator. So in mathematics, what equal to means? Equal to means whatever is on right side, okay, will be copied to the left side. So the same meaning applies to here as well. So the only difference in assignment operator and copy constructor is that copy constructor is called when during the object creation of the copy constructor is called when you want to create a new object with an existing object. Okay, example this one as we seen in the copy constructor examples. So this is copy construction. Okay, now let's say you already created another object obj2. Okay, so obj2 is already created. Okay, let's create a new address for this obj2 address 2. Let's assign the value as kr1. Let's input as 4. Okay, so I'll remove this assign copy construction. So now I have two objects obj and obj2. So in your project somewhere you want to assign obj2 to obj, this one. So this case copy assignment operator is called. So this mathematical equal to symbol only knows about built-in data types like integer. If you do equal to an integer or character or double, so it will automatically assign this value to this value. But this obj is a complex object. It's a user-defined object. So this user-defined object has heterogeneous data types. It can have multiple data types. It can have any other complex data type inside this. So when you have such a type, when you're copying this object to this object, so we need to take care of a lot of things, right? Because it's not a direct copy. So let's try to compile this. Let's understand one by one. Let's try to compile this and see what happens. Obj equal to obj2. Obj equals to obj2 I did. So I'm calling assignment operator here. Here you see I have not written any assignment operator. There is no compilation error still. Why? Because if there is no assignment operator written by us, compiler will generate on its own one of the assignment operator. Okay. Now, what is the drawback? Why this double fee is coming? So can you guess? Whatever we discussed in copy constructor, same concept applies here as well. So why this is causing double fee? Okay. Any idea why? Just take a pause and understand why this is a double fee. Why this is this is causing the issue. So let's say if I comment this, let's see what happens. Now there is no double fee error. So take a pause and think about it, why it is causing the double fee error. Okay, let me explain. See, when you copy this obj2 to obj, what is happening? So by default, compiler will generate its own assignment operator, but that will do again what? Shallow copy. Okay, as we explained last time in a copy construction session, shallow copy will just copy the data members as it is. Okay, so example, it will copy age to age, name to name, address to address. So by this, what is happening? Again, obj2's address, this address, and obj's address becoming same. Okay, so both are now obj and obj2 both are pointing at address 2 only, which is a common shared address now. Because of this, what is happening? It will, when obj and obj2 goes out of scope, automatically the destructor is called. So first time the destructor is called, it will delete it, and for the second obj again the same destructor is called, but this time again the address is same, right? It is pointing to the same memory address. So the memory address is already deallocated, right? It is already feed. So we are trying to feed again one more time. That's why it is causing double fill. Okay, and there is one more issue here. So can I explain what is the issue? Again, take a pause and think about it. So let's say when you copy obj2 to obj, what is happening here? You have created one address already in heap, and this is second address. So this address, this obj's address is v assigned of v point to address 2. So let me put it in a diagram so that it will be easier to understand. Okay, let's say initially I have address addr, then I have what? Obj. So this obj, what it is having? It is having 20. It is then the value is Philip. Then let's say the address of this is was 2000. Okay, so this will be pointing to this memory location. 0 plus 2000. Okay, here we have what? MG board. Okay, then we have this pin code, so which is 56003 for this is for obj and the address. Then I'm creating a second one, so which is obj2. obj2, this is again is having same 20, here also the age is 20 and the name is Philip, same name I'm using. here the address is again a new address. This is new address. Okay, again it is having the value kr program. Then it has pin code 560-034. Let's say this is at memory location 0 plus 2 sorry 3000. So 0 cross 3000. It is being copied here. So this is how it is obj1 and obj2 looks like. When we see at line number 80 obj equal to obj2, what is happening? So in this case this 20 is being copied here. This is what the compiler's assignment operator do. This Philip is again being copied here, and this 200 is also being copied here. So it will be overwritten with 300 is overwritten with 200. So this link is discarded, right? And this will again point to this one. Okay, I did the other way, but yeah, let me put it this way. obj to equal to obj. So obj2 we are assigning obj. So this link is discarded and it is pointing to this one. So again this will have a same problem like a shallow copy, right? So this is a shallow copy. What is happening? It is when obj goes out of scope, this address is deleted, and again when obj2 is going out of scope, again it is trying to delete this address, but this address is already deleted by obj. So this is causing a double free issue. And another issue is here is that so this link is reassigned, obj2's link is reassigned to point to this address, but what happens to this one? What happens to this memory? This is not freed at all. Okay, this is a memory leak. This much of the memory from the system, whatever we have taken, we have not given it back to system. Okay, so this will be never given to the system. So this memory is not deallocated, hence this is a memory leak. This is a very dangerous situation, right? So these are the problems if we rely on compiler generated copy assignment operator. So it is always a best practice to have our own copy constructor to avoid such problems. So let's see how we can avoid these problems by writing our own copy assignment operator. So let's write our copy assignment operator. Okay, so this has a return type of person class, then operator. This is a syntax. This is a type of operator overloading. So we have overloading equal to operator. Then inside this we have const person obj. So the reason for const is same as what I explained in the copy construction, and the reference is again here is required because if you don't use a reference, again this will invoke a copy constructor. This is again a costly operation. So now let's write copy assignment operator. So copy assignment operator is called when we already have two existing object and we are trying to assign one to another. In this case, so there can be a possibility that same object, example, same object is assigned to the same object. This is also a possibility, right? So in order to simply copy, in this case we can put this check. If this is a pointer pointing to an current object, in this case this one, the left hand side object. If this is the address of this is equals to address of obj, if this is the case, then it is self reference. Okay, cout self copy. In this case, what we can do, we can just return star this. Why star this? We are dereferencing this because the return type of this is object. Okay, so we need to dereference this pointer and return it. Now let's say if when we have a pointer types in our class, such kind of issues exist, right? So as I told, there is a memory leak here when you are copying. So now to avoid this memory leak, we need to deallocate this memory. Okay, for the whatever allocated for the first object, we need to deallocate that first, and then we need to create a new memory for this one. So now to do that, let's put a check. If this of address, if it is present, first delete that, right? So first we need to delete that. If at all the address is present, okay, so yes, it is present. So first whatever is there in this address, first we need to delete it before copying from the second element. So first we need to delete it, means it will be this cap term is deleted, then we will have to copy this. So we need to avoid a shallow copy, we need to do a deep copy. So let's do that. So let's write this for the seeing the output. Copy assignment operator. Here this of underscore age equal to obj dot underscore age, this of underscore name equal to obj dot underscore name. Now this of underscore address equal to, if we do obj dot underscore address, what happens, this will become a shallow copy. So in this case, this is what default assignment operator is doing. So it is just copying this 0 cos 200 value to this one. So which is again what happens, it will be pointing to the same memory address. So this is wrong, we should avoid this. Okay, never do a shallow copy, that will result to a undefined behavior. So instead what we can do, we need to allocate new memory location for this address. This address equals to new address new address. So what are the arguments? First argument is object dot underscore street, object dot underscore street, then object dot underscore pin code, right? So these two we need to copy to that memory. So we have, what we are doing, we are creating a new memory of this address type. Okay. And then we are copying this mg root here, here. So basically if I put it in a diagram, so what is happening, if I explain this, so this first thing at line number 57, I am deleting this I am deleting, this link is deleted. And then at line number 64 and 65, I'm copying 20 here, fill it here. And line number 67, I'm creating a new memory address. So this is previously, this is what happening, this is not there now. So in this, let's see what happens. What I'm doing, I'm creating a new memory address. Let's say this memory address is 0 cross 400. Okay, so here what we'll have, 0 cross 400. So it will be pointing to this location, and here I'm copying whatever is there in here. So MG I will copy, and this pin code I will copy. So I first allocate a memory, I copy these things and assign it to this address. So this will be having its own copy. Now if we compile this program, so this double free problem should be solved. Options has no member named street. Okay, I think object dot underscore address dot get street. So object is again a person type. From that object I need to look for address, and that address I need to get the pin code and the street. Okay. Control which is end of non-void function. Okay, I have not written. I need to return this. Return this object because the return type of this assignment operator is person. So I need to return the person object. So as you can see, it is the double free above is gone. Now it is calling self copy. So self copy because it is assigning the object to itself. This is a self copy. Now let's say if we put obj2 here, this is calling copy assignment operator. So let's print it just to understand. Obj dot get address get street and after this assignment let's print this. Okay, this was MG code. After the copy assignment operator, this is KOP. So this is a clean way of writing your copy assignment operator. So always remember, when you have pointer types, you should not do a shallow copy. You need to have a deep copy. You need to write a deep copy assignment operator. Don't rely on the compiler generated copy assignment operator. So as I explained, this has many problems like shallow copy and the memory leaks. So to avoid all these things, you should write your own copy assignment operator like this and put some checks like this, so that you don't want to assign same object to same object again. And you need to clean up the memory first to avoid the memory leak. This is to avoid memory leak. Otherwise what happens, so if you overwrite this address here, so the previously allocated address at this address, previously allocated memory is never fed. So that will be a memory leak. So I think that's all. So yeah, the syntax is like this. The return type is class name and the ampersand because we are having a reference. We want to give the reference. It should not be a value. It should not be like this. It should be a reference only because we need to we are we want to recursively copy the object. Okay, and operator equal to then const person ampersand is for the same reason. Const is for the same reason why I explained for the copy constructor. You don't want to modify the referenced object here inside this operator. And again, to if you want to assign uh, temporary constant objects to a new object, so this const is necessary, otherwise the code will not compile without const. So these are the major uh, things about copy assignment operator. How to write your own copy assignment operator, and when the assignment operator is called, and then what are the issues if you don't write your own copy assignment operator. So there are two type of issues, always remember. One is when you have a, complex objects like this pointers, so it will cause a memory leak. If you don't write your own copy assignment operator, it will cause a memory leak, and again it will also cause double free. Okay, because you have a shared address pointing to the same location in both the object when you copy. So this will cause undifferent behavior, and also your program might crash. So this is a very hard program to debug. So when you write your class, you must write your own constructor, your copy constructor, and assignment operator and destructor. So these are the basic things, basic building blocks of your class. Okay, whatever class you write, you need to write all these things properly by yourself, because you have, this is your own class. Okay, you are creating these objects of this class, and you know better how to manage these objects. So it's always better to write your own constructor, copy constructors, assignment operator, and the destructor. Don't rely on the compiler generated constructors and destructors and assignment operators. So for simple classes it is okay, but for the complex classes you have to write your own. So that will avoid lot of problems, lot of debugging later point of a time when you have issues. I think that's all from copy assignment operator. See you in the next session. Thank you.